I will hit record. Yes, so there is tutoring on Sunday from 3 to 7 in the lower level of Shields Library. So, straight out that window, but down. Unfortunately, there's no entrance on this side, so you got to go to the other side of the building, but it's down in the lower level. There's kind of, if you haven't been down there, like if you walk down the stairs, there's it's kind like of a empty room. Yeah, and one part of that room has all of our tutors in it. They're wearing like blue shirts. Like a uniform? They're wearing shirts that are about this color. Yeah. And let's see. So they are there 3 to 7 on Sundays, 11 to 4, Monday through Thursday. And does anyone offhand know the hours for Friday? 11 to 1. Thanks. So 11 to 1 on Fridays. Yeah. And you can also make individual appointments with a tutor through our Oasis system, and that you can have up to 60 minutes with a tutor. And the hours for that kind of range because it's dependent on what hours the tutor lists for availability, but some of those go certainly till like 7 or 8 at night. I don't know whether any of the 16B tutors specifically offer tutoring hours that late, but that is another option in terms of tutoring help. So what are we going to practice? Indefinite integrals. Cool. Should I make some up? Or we can definitely take a look at problem 3 on the practice exam. What did I do with my practice exam? I got it somewhere in here. Oh, I conveniently set it off to the side for no reason at all. So yeah, let's take a look at problem 3. From the practice exam. So that first one on problem 3, we're looking at the integral of 5x cubed over the square root of 2x to the 4th plus 1 dx. Well, I'm going to walk up to this lovely integral and say that's just algebra because I have x's raised to powers. If this 1 were not there, then I could totally just rewrite everything with the magic of exponent rules. But that plus 1 inside the square root is causing a problem. So I'm going to say, does the derivative of one part kind of sort of equal the other part? And it kind of sort of does. We're just off by a number. Oh, I didn't mention this the other day. I said we were doing some U substitution, but I forgot to tell you, U stands for the ugliest part of the problem. What's the messiest part of the problem here? That square root garbage. So I'm going to let U be equal to 2x to the 4th plus 1. And then build my vocabulary list so that I can translate the problem into something that we can answer. Well, if that's U, then in terms of building my vocabulary list, sorry, I need a du, or the derivative. And when I take the derivative of 2x to the 4th plus 1, I get 8x cubed. I'm adding in my dx, or rather multiplying in my dx, because it would be like a du over dx over here, but I'm multiplying both sides by that dx. Now I have my vocabulary list, and I start looking at my problem for how I'm going to translate things. Well, the denominator just became the square root of u. But in the numerator, I don't exactly have the right thing yet. So what I have in the numerator, I have an x cubed and a dx. So I'm going to take my vocabulary list, divide both sides by 8, so that 1/8 of du is equal to x cubed dx. Now my vocabulary list is in good shape, and I can swap things out. We still have that 5. Numbers are okay. We don't need to be afraid of numbers. And then x cubed dx, that's what we're going to swap around to say 1/8 of du. Now that's just messy to look at. One of our options that we have when we're working with integrals is if there's a constant being multiplied by it, we can like factor that constant out in front of the integration symbol. And that's because when we take derivatives or antiderivatives, if we're multiplying by a constant, they just kind of come along with us. So I can choose to take that 5 times 1/8 and write that as 5/8 out in front of the integral. And I just think that that makes it easier to see what we're doing. Now we're set up in a good spot to find the antiderivative. And to do that, I'm going to want to rewrite that as u raised to an exponent. Yeah.
I have a question. So when we see indefinite integrals, we just automatically do the u sub, or is that more?
No, but these two problems both happen to be u substitution. So indefinite integrals just means you're finding an antiderivative, and there's going to be a plus c at the end. Now, the reality is there's a time constraint in terms of your test. So if I really only have time to ask you a couple of indefinite integrals, I'm probably going to ask you u substitution problems, because that's going to force you to demonstrate both just how do you find an antiderivative, but also doing a u substitution. But no, it is not that every indefinite integral is a u substitution problem.
It's just when it looks messy.
So we're going to spend like 5 weeks building up more tools for finding antiderivatives. At this moment, this is the only tool we have. So if it looks messy on this test, it's probably a u substitution. Yeah. But we will have more tools. So to move forward here, like this is the part where now it becomes just an antiderivative problem. I'm going to rewrite that. We're not finding the antiderivative yet. I'm just going to rewrite that as u to the -1/2 so that we can use our antiderivative rules, like the basic power rule for antiderivatives, meaning I add 1 to the exponent and divide by the new exponent. So I'll have 5/8 times u to the 1/2, and then the whole thing divided by 1/2. Really the piece that is like making this an indefinite integral is the fact that we're going to end this problem with a plus c. We don't have additional information to know exactly which function that's the derivative of. But now we found like the family of functions that it belongs to. Should we look at the next one on here? Question.
On the grading scale for the test, I don't want us to sub x back.
Oh, you're right. I totally skipped that part. And we were definitely doing that the other day. And yes, we definitely should plug the u back in. Going back to my analogy, we have now, and the question started in Danish, and then we translated it to English so that we could answer the question, but we forgot to put it back into Danish, which is what our teacher was going to grade us in. So we better send that back. If everybody's okay, dividing by 1/2 is the same as multiplying by 2. So I'm going to write that as 5/8 times 2/1. And then 2x to the fourth plus 1, all to the 1/2 plus a constant. Good times. Might as well finish off the other one from problem 3 also. So the other part of problem 3, we've got an integral of x squared times 1 plus x cubed whole thing cubed dx. And I will actually start by saying you really do have a choice here. You could just multiply all that stuff out. But it's going to take a minute. And so I wouldn't. Because we have kind of, if I stand back and look at the overall structure, I've got x squared and then times this thing that's cubed. I would pause and do a quick check. Okay, is the derivative of one part equal to the other part? Kind of, because the x squared has a power that's 1 less than the 1 plus x cubed. So I would come off to the side and build my vocabulary list and have u is equal to 1 plus x cubed. When I take that derivative, then I've got du is equal to 3x squared dx. And then I look back at the original problem. What I have in the original problem is x squared dx, not 3x squared. So I would either multiply both sides by 1/3 or divide both sides by 3, whatever feels better in your head. I think I like the multiply by 1/3. And now I can make those substitutions. So the x squared dx part becomes 1/3 du. That stuff in parentheses was u, and it was all raised to the 3rd. It is a personal choice to move that 1/3 out in front. I just think it helps me to focus on the antiderivative part. So then when I'm finding the antiderivative of u to the 3rd, we're going to add 1 to the exponent and divide by the new exponent. So I'd have 1/3 u to the 4th divided by 4. Don't forget our friend plus c. Dividing by 4 is the same as multiplying by 1/4. So that would actually be 1/12 u to the 4th plus a constant. And then because we want all of our points, we're going to switch that around to say 1/12 of 1 plus x cubed to the 4th plus c.
How'd you get 112?
So that 1/3 divided by 4. If I have 1/3, dividing by 4 is the same as multiplying by 1/4. So that's how I end up with 1/12. So there's a question in the chat about like how we're actually making the substitutions. And yeah, because 1/3 of du is equal to x squared dx, when we substitute that into the problem, we take that entire x squared dx part and we replace it with 1/3 du. And that's at the heart of a u substitution. Like that's the thing that we're doing. Just to address the, like, is every indefinite integral a u substitution? I could just have something, I'm gonna make it a little bit messy, but not crazy messy. If I had, let's say, x cubed times x minus 1 squared dx. So this is another indefinite integral. And I would look at that and say it's just algebra. But this time, the derivative of one part isn't equal to the other part. That x minus 1 in parentheses, well, the derivative of that is just 1. So it wouldn't actually help deal with the x cubed. So this problem right here, if I had to find the indefinite integral, a u substitution wouldn't help. We actually just have to multiply that out. And you might think, oh, well, what about what if I took that x cubed part to be equal to u? But that derivative is x squared. And we don't have or 3x squared, but we don't have an x squared just sitting in there. So to finish this problem off, I would have to just do the algebra. So x minus 1 squared would be x squared minus 2x plus 1. And then I would distribute the x cubed in and have x to the 5th minus 2x to the 4th plus x cubed. And then we would take the antiderivative. No substitution happening. Just using our basic rule. We add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. What else do we want to practice? And I can make up u substitution problems all day. So if y'all want to just keep on this train, we can do that. Yeah.
Can you go over problem 2, part 1?
Yeah. So problem 2 on the practice exam. I am looking at f of x is equal to e to the power of negative x to the negative 1/3. And we have been asked to take the derivative. Just in terms of like derivative rules that we should make sure that you've got memorized for this test. If y equals e to some stuff, then y prime is e to that stuff times the derivative of the stuff. So if I cruise on over to this problem, e to some stuff, so I get e to all that stuff again, times chain rule says I need to take the derivative of this. Well, negative 1/3 times a negative would make that a positive 1/3. And then if I subtract 1 from the exponent, I'd have negative 4/3. I know that the solutions made it look slightly messier, but that's just because he kind of rearranged this to sort of match a chain rule formula. But you don't have to do that. You can just correctly apply the chain rule and you would get full credit as long as you correctly apply the chain rule. Question in the chat from problem 1. And problem 1 is like all that true false stuff.
Yeah.
And so the third part of problem 1 starts out as e squared to the 4th. And then there are some other things. We've got e raised to the 2 to the 4th and e to the 16th. So just kind of going back to our what happens with exponents. I'm going to take this very first one, and raising something to the 4th power means that I'm multiplying that thing by itself 4 times. So if I were to expand this out, that would look like e squared times e squared times e squared times e squared. Or each of those is really an e times an e. I'm buying us time here, but that is definitely e to the 8th. Because powers raised to powers, I'm going to multiply those. So these two things are not equal. However, these two are. Because for this one, I could do that work. 2 to the 4th is 16. So these two are equal, which means overall we have to say that it's false. Because one pair is not equal. Other questions, either from the practice test or things you want me to make up problems about?
To clarify for problem 1, the first one, would that be the same? Like it's just rewriting it?
It is not. So the first one on problem 1 looks like natural log of 10 divided by natural log of 7. That, I got nothing. Like, I don't know what else I would do with that. However, natural log of 10 divided by 7, that's the same as natural log of 10 minus natural log of 7. Yeah.
You can't see it.
Oh, sorry. Yeah. So if that had been the statement, this statement would be true, but these two things are not equal. Other questions or types of questions you want me to make up examples for? Yes.
Can we do another sub problem that mimics the second problem we did?
For sure. I'm gonna get rid of this. So another U substitution problem. Should I make it tricky? How are we feeling? Okay, maybe I won't make this one tricky. We'll get towards tricky. It actually does have a little bit of trickiness to it, but it's not quite as tricky as I was gonna make it. So it is gross. Given time, energy, and sufficient monetary motivation, you could multiply that garbage out and probably do some sort of algebra with it. But nobody's got time for that on a test. So I'm going to look at that and I'm hoping, does the derivative of one part equal the other part? There's really only two parts. So if you're not sure what to do, pick one and take the derivative and see what happens. I'm going to pick the part that's messier. The 4 minus x to the negative 2. Well, when I take the derivative of that, derivative of 4 goes to 0. Bring that down, minus and minus, so that's positive 2x to the negative 3 dx, and we're in luck. That's almost what we have in the original problem. What I have in the original problem is an x to the negative 3rd and a dx. So I just need to take half of both sides here to get my substitution. So all this stuff in parentheses, I get to call u, which means I've got u to the 4th, and then the x to the negative 3 and the dx, that gets to switch around to be 1/2 du, or I can put that 1/2 out in front. Now I can use the antiderivative rules. Add 1 to the exponent, divide by the new exponent. Since I'm going to be dividing by that 5, the bottom is really going to look like 2 times 5, or be 10. And then my last step is to plug back in what the u was. So 4 minus x to the, negative 2 to the 5th divided by 10 plus a constant. And there is a request in the chat to work through problem 4. So I will plan to do that next, but I'll pause here in case there are questions about this one. So I don't even think that you have to simplify the fractions if you don't want to, but for sure on that last step, I could have thought about this as 1/2. We're going to add 1 to the exponent and divide by the new exponent plus a constant. Like whenever, that's our basic power rule for antiderivatives. Add 1 to the exponent, divide by the new exponent. I just simplified that fraction and said, I know that I'm going to be dividing by 5. So that's the same as multiplying by 1/5. I really honestly don't think he would care if you left it like this. So there's a request to take a look at problem 4. So let's look at problem 4. A sample contains some radium whose mass decays exponentially. The half-life in years is known to be 1,599. suppose that after 500 years, there are 2 grams of radium left. What is the initial mass of the radium in the sample? So first of all, because we're talking about exponential decay, I'm already thinking y equals CE to the KT. In general, I need 2 pieces of information anytime we're doing these problems because I have a C to solve for and a K to solve for. Well, this one, we were given those 2 pieces of information in a slightly non-traditional way. The first one is that we were given the half-life. So rather than being given the initial amount C, we were told how long it would take for half of it to decay. Well, that means that sort of that second one of those pieces of information we have is that y would equal 1/2 of C when the time is 1,599 years. The other piece of information that we were given is that when time is equal to 500 years, y was equal to 2 grams. There are different ways to work through this problem. And if you have, the textbook gives us a formula that relates the half-life to the K value. And so if you have that memorized, it's totally fine to use it. I don't actually have it memorized. I'd be lying if I said I did. I'd be like trying to work out the math really fast in my head. I don't actually have it memorized, so I'm going to work it out. So I'm going to take that first line and plug everything in so that I end up with 1/2 of C is equal to CE to the K times 1,599. Well, I can divide both sides by C so that I don't have it in the problem anymore. And just have 1/2 is equal to E to the 1,599K. And to get that K by itself, I can take the natural log of both sides. So natural log of 1/2 would be equal to 1,599K, or K would be natural log of 1/2 divided by 1,599. Good times. Well, now that I know what K is, we ought to be able to go back and get the C value. So I'm going to take a look at the other piece of information we were given, that y equals 2 when t is 500. So I'll have 2. Sorry, my pen doesn't want to work today. It's been overused or something. Let's try a different color. So 2 is going to be equal to C E to the all that garbage, ln of 1/2 divided by 1,599 times the t of 500. Now, you've been told that you don't have to simplify things. So if I didn't simplify things at all, then I could just say that C was equal to 2 divided by all that garbage. If you wanted to clean that up a little bit, then we could certainly do something with the E and the ln if we first dealt with the 500 and the 1,599. But I wouldn't. I really would just leave it alone. Whatever that is. There is not an expectation. If you don't have a calculator, there is not an expectation you're moving forward from there. That's just what the answer is. Gross as it may look. Got about 15 minutes left. What else are we doing? Questions about this one?
Yeah, I just want to know
Oh, yeah, so because we don't know what the initial amount is, but the C in the formula means the initial amount, like that's what the C value is. After one half-life, we should have half of that initial amount. So if C had been 100, then after 1,599 years, Y would be 50. The issue in this problem is we weren't given the initial amount, so we have to just drag around C like it's a placeholder. Yeah, if we had just written Y equals half, that would have implied that we started off with 1 gram. But we don't actually know that. We know that we started off with C grams, and after 1 half-life, we should have half of that much. Other questions? And again, I'm happy to make up questions, so. Yeah. So the second one from problem 2 on the practice test, we are looking at trying to get that to focus. Okay, so g of x is equal to the natural log of x plus 1 divided by the natural log of x squared minus 1. Well, the first thing that I want to say is that although we could rewrite the bottom to be natural log of x plus 1 times natural log of x minus 1, I don't think it gets us much. Because it would turn into subtraction in the denominator, that doesn't it doesn't simplify anything. I personally think it makes it worse. So I say we just go take the derivative. Well, this is definitely going to be a quotient rule. I'm going to choose to call the top F and call the bottom G so that I can do F prime G minus FG prime all over G squared. When I do the quotient rule, I put in the stuff that I already know. Oh, it's going to be confusing because that's a G prime. Okay. Using different notation just because I had a G. But I know that the bottom is going to be ln of x squared minus 1 whole thing squared. Partial credit? No, probably not. But maybe it's worth a point. Honestly, writing the quotient rule might be worth a point or two, like demonstrating that you know what to do. So if I take the derivative of the top, natural log of x plus 1, that derivative is going to be 1 over x plus 1 times the derivative of x plus 1. But I'm going to leave off the multiplying by 1 if that's okay. Then we're going to leave the bottom part alone. So I'll have ln of x squared minus 1 minus, leaving f alone, ln of x plus 1 times the derivative of the bottom. We've got natural log of some stuff. So that derivative will be 1 over the stuff times the derivative of the stuff, which is 2x. This problem did not say that we had to simplify our answer. So I probably wouldn't. Now, if you really wanted to, you could. It is not clear to me in terms of looking at it is not clear to me why you would go to this last step. There's nothing about this problem that said you should simplify it as much as possible. So I would have quit there because nothing told me I had to do otherwise. I am happy to fight through algebra with people if you want to make it look like that. Does anybody want to fight through the algebra? Yeah, I wouldn't. I would walk away. We took the derivative. We are done.
Yeah, on the provider just stop at that point.
Oh, did he? Okay. It looks like he split it up into like he did this minus this. I don't know why. Because it felt like fun or something. Yeah. Other questions or types of questions you want me to wake up? Yeah, there's a request in the chat to do another exponential example. So let's say that initially a colony of bacteria. Is that what you call it? A colony of bacteria? It sounded weird when I wrote it, but I think that's what they say. So initially a colony of bacteria has 400 bacteria. And it's growing exponentially. After 3 hours, there are 500 bacteria. When will the sample have over 1,000 bacteria? Okay. Got my fictitious colony of bacteria. We start off with 400. It's growing exponentially. And after 3 hours, there are 500 bacteria. So when will the sample have over 1,000? Anytime we're talking about exponential growth or exponential decay, either way, I'm reaching for y equals CE to the KT, and I'm looking for 2 pieces of information. Well, here we've got initially 400 bacteria. So y is equal to 400 when t is equal to 0, or c is equal to 400. That second piece of information, I know that after 3 hours, there are 500. So y is equal to 500 when t is equal to 3. So whether it's exponential growth or exponential decay, either way, I'm kind of starting off approaching it the same way. Well, this time I was nice and I gave us the initial condition. So we can just start with 400 e to the KT. Oh, and I guess I could go ahead and say what we're looking for. So when, as a question, is asking what time, and if I need to get over 1,000 bacteria, that's going to mean that y would be 1,000. So that's like the question part that we're aiming for. So if I use this second point, that's going to let us find a value for k. Even if the value for k is messy, it's usually messy. I made mine not quite as messy as whatever it was last time, natural log of 1/2 divided by 1,599. This one's not so bad. To get the k by itself, we don't want to take the natural log of both sides yet. We want to isolate the e to the stuff part first. So I'm going to divide both sides by 400, which will make this 5/4 is equal to e to the 3k. Then I'm ready to take the natural log of both sides. Which means that our k is 1/3 ln of 5/4. Once we have the c and the k, then we basically plug everything in to solve for whatever question we were asked. So in this case, we were asked for a time. So I've got my k, I've got my c, I've got my y. So putting all those in, 1,000 is equal to 400 e to the 1/3 natural log of 5/4 t. And to get the t by itself, I know that I'm going to have to take the natural log of both sides again, but I want to deal with the numbers first. So 1,000 divided by 400, 2 of those zeros are going to drop off and have 10/4, or if you prefer, 5/2. But I've got 10/4 is equal to e to the 1/3 ln of 5/4 t. And I take the natural log of both sides, ln of 10/4. Over here, that's going to drop the e. And kind of like the problem on the practice test, I am going to leave this all kinds of messy and just say t is equal to ln of 10/4 divided by 1/3 ln of 5/4. And there's a question in the chat about how I knew that c was equal to 400. Two options on that. One is just that we kind of memorize, or we've done enough of the problems that we recognize that c is the initial condition or the initial amount. But the other thing is, if you plug in 400 for y and 0 for t, it's just going to pop out for us. So if I had plugged in 400 for y, this would have turned into 400 is equal to CE. And then if t is 0, that'll be e to the 0. But e to the 0 is equal to 1. So c is equal to 400. Or we can also just remember that that's always what's going to happen when we plug in 0 for t. So that c value is the initial amount. We are out of time. I'm going to stop the recording.